Quadratics, as far as algebra goes, quadratics are important because they apply to everyday life. Linear equations, quadratics, and exponential equations are important in algebra because they apply to everyday life. When you get to x to the third, x to the fourth, x to the fifth polynomial equations, some aspects of engineering will use those, but in general, you really don't need to know those. You just really need to know linear equations, quadratic equations, and exponential equations. As I said before, the important part of quadratics is the part where it bends around and where it crosses the x-axis. So if you have an equation or a graph that kind of looks like that, the part we really care about is this part right here. Okay, if you have one that kind of does this, the part we care about is this part right here. We really don't care about this so much. We don't care about this so much. Okay, it's really where it crosses the x-axis right here and where it turns around right here. Those are the important parts, okay? So that is what we really try and do when we solve quadratic equations. So essentially, a quadratic equation or a parabola, when it crosses, what we're really trying to do is find the points that it crosses the x-axis. And we know that it does that. Those are the x-intercepts. Okay, we have a y-intercept in this case down here, and we have two x-intercepts. So the x-intercepts, sometimes they're called roots, sometimes they're called x-intercept, sometimes they're called zeros. Why are they called zeros? Because we find them when y is equal to 0. What is x equal to? Okay, sometimes they just say x is equal to, or solve for x, or what's the solution of x, or what's the solution of this problem. Okay, so there's several different terms that you use. Roots is very common, zeros are common, or what is x equal to common. So it's important to know, how do we solve for x when y is equal to 0? Well, there's a couple ways we can do that. The first way is by factoring. If we have x squared plus 4x plus 4 is equal to 0, that's why it's important to set it to 0. Okay, because now if we factor this, we can say that this is x plus 2 times x plus 2 is equal to 0. Now the zero factor property says that if we have a product of anything and equal to 0, then one of those factors, or all of them, must be equal to 0. So in order for this to equal 0, one of these two terms, or both of them, have to be 0. So we solve them for 0. If x plus 2 is equal to 0, that means x is equal to negative 2. And same here. It's the same thing. X plus 2 is equal to 0, then x is equal to negative 2. And what that tells me is that this parabola crosses the x-axis at x equals negative 2. And if it does it twice like this, in other words, if these two factors are identical to each other, that means it comes down and just touches the x-axis at this point, x equals minus 2. Okay, and we saw that earlier when we graphed it. We saw that because that equation, that same equation, x squared plus 4x plus 4 is equal to 0. The square should go on top there, x squared. Okay, we saw that it intercepts at y equals 4, and that it came down right there at minus 2, and just touched, and then went back up again. And that's all it says, okay? When I solve for x and I get x equals minus 2, that just tells me that it crosses or touches the x-axis at minus 2. And in this particular case, it's duplicated. The two factors are x plus 2 and x plus 2. So that means x is equal to minus 2 and minus 2, but we don't need to write it twice. We just know that if there's only one and it's the same, then it touches. If the parabola came down like this, and this was, let's just say, minus 6, and this was positive 2, then we say x is equal to minus 6 and 2, and we know that its factors would be x plus 6, x minus 2. Okay? Because the factors are always going to be the opposite sign of the roots. These are the roots. Factor is going to be the opposite sign, and then you put an x in front of it. So if I look at this minus 6, I change the sign to positive 6 and put an x in front of it, and that's one factor. If I know this root is 2, I change the sign, negative 2, put an x in front of it, and x minus 2, and that's the other factor. And that's how you get factors and roots. Next, we'll look at how we get roots and factors on a calculator, which is much easier than doing it the long way up here.